Hello everyone, welcome back to my channel, LeetCode. And today let's practice this question, minimum cost tree from leaf values. Given an array of positive integers, consider all binary trees such that each node has either 0 or 2 children. The values of array correspond to the values of each leaf in order traversal of the tree. The value of each non-leaf node is equal to the product of the largest leaf value in his left and right subtree, respectively. Among all possible binary tree considered, return the smallest possible sum of the values of each non-leaf node. It is guaranteed this sum fixed into a 32-bit integer. And a node is a leaf if and only if it has 0 children. So here we are given an example 1. The array is 6 and 2 and 4. So in this array, we can have 2 kinds of tree. So the first tree, we put the 6 and 2 together and 4 itself. So first, we have to consider this node, that is the maximum value of his left subtree and right subtree, the product of the maximum value of left subtree and right subtree. So that is 6 multiplied by 2 is 12. And for this value, how does it calculate it? It is the maximum value of his left subtree. It is 6 here, multiplied by the 4 here. So that is 24. We want to find out the smallest possible sum of values of each non-leaf node. So here the sum is 12 plus 24. It is 36. So that is the one possible solution. And the another possible solution is like this. So we have 6 and 24 and 2 and 4. Here we have a 2 and 4. So how do we calculate this number? It is the maximum value of the left subtree, it is 2, multiplied by the maximum value of the right subtree, it is 4. So it is 8. And how do we calculate this number? It is 6 multiplied by, so the largest number of the right subtree, it is the 4. We only consider the leaf node, so it is 4. So we multiply by 4, and that is 24. And the sum here is 24 plus 8. It is 32. So since the 32 is smaller than the left tree 36, so the 32 is our answer. Now think about how do we build the tree from the leaf node. If the leaf node has the elements like this, we have a 1, 2, 3, 4, 5. We can have a division like this one. We can have a 1 as the left subtree and 2 to the 5 as the right subtree. And or we can have a 1 and 2 as the left subtree and 3 to 5 as the right subtree. And or 1 to 2 to 3 as the left subtree and 4 and 5 as the right subtree, right? Inside each tree, we can further splitting it into a left subtree and right subtree, so we can have a 2 as its left subtree and 3, 4, 5 as a right subtree, or we can have 2 and 3 and 4 and 5. etc. So as we are given an array, just one array, but there are multiple ways to build the binary tree from the leaf node, from the array. So we have to find out the smallest possible sum of the values of each non-leaf node. So how do we calculate it? The brute force way is to build all the trees, all the possible trees from the array, and then find out what is the minimum sum value. So let's build a tree from the example 1. So now we have a 2, 6, 2, and 4 array. So the first thing is we can split the array like we have a 6 as the left subtree and 2 and 4 as the right subtree. Here we know we have a 6 and here is an unknown value. So these two are unknown values, and we have a 2 and 4 as the right subtree. So every time we have an unknown value, we want to know what is the maximum value of his left subtree and its right subtree. And also we want to know what is the sum of his children, because if we have these children, this node, if we can have the sum from his children from this one and this one, let's call it A, let's call it B, and also is so the value itself, so let's call it C, and then we can return the A plus B plus C to his previous parent, let's call it D, and then we can have a D plus A plus B plus C plus from his left subtree. Then this is the sum of the values of the tree, and we want to find out how we can make the sum as small as possible. So we can have a recursion function, and for each node will return the maximum value and the sum to his parents. So for this node, the maximum value is 2 and the sum is 0, because we don't want to conclude the leaf node in our sum. So when it is a leaf node, it will return a 0 to his parent. And for this part, we'll return the maximum value is itself 4 and the sum is 0. For this one, what we would like to return? So the return is the maximum number of the tree. So to this parent, these two nodes is right subtree. So the maximum number of the right subtree is the maximum number of 2 and 4. And also we want to return the sum value. So what is the sum value? The sum value is we have a here is 0 and the 0 comes from here, and the value of itself, so that is the maximum number of its right subtree is 2 multiplied by the maximum number of the right subtree, it is 4. So we have 8. And now back to the root node. So for the left subtree of the root node, we will for this node we will return the maximum value is 6 and the sum is 0. For the root node, if it has a parent, what we would like to return, so the maximum value is maximum of 6 and 4, and the sum of his children is 0, from this 0 and 8 from the here, and plus the value itself. So what it is the sum of left subtree and right subtree multiplication. So that is 6 multiplied by 4, 8 plus 24. So that is 32. So our answer is 32. So here is the one way to calculate to build a tree. Then we can have another way to build a tree. So we can have 6 and 2 together and 4 itself. So we'll have 6 and 2 together. So here is unknown value. And we'll have a 4 here. So here is unknown value. So here we'll return the maximum value 6 and the sum 0. And here we'll return the maximum value 2 and sum 0. So in this node, what it will return the maximum value of 6 and 2, and also the sum. So the sum is the sum of its children, 0 plus 0, and the value itself. So it is 6 multiplied by 2. So that is 12. And here we will return a 4 and 0. So what is the value of this node? The return value, that is, okay, so let's finish this calculation. So the maximum of 6 and 2 is 6, and the sum is 12. So in the calculation, it will have a maximum value of from 4 and 6, and plus, and the sum is the sum of its children, 12 and 0, and the value itself, it is 4 times 6. 32 is smaller, so 32 is our answer. Basically, if we, for each node, we would like to have a function, let's call it just calculate, and then like for example, if we have this node, then we know its left part and its right part. So we would like to have its left boundary, its right boundary. And then after this calculation, we'll return a tuple. It is the maximum value and the sum. Maybe we here in this boundary, we have multiple elements here. So actually the nodes here are more than just 2. So we can have a array like this one, and splitting like this, and this, or this, and this. So in every splitting, we will have a sum for each way to splitting the array, and then we would like to keep the smallest possible sum. But in order to make our code or software to run more efficiently, we would like to have a cache to cache the left and right range. So we'll have a cache, and we'll have the key of the cache is the left and right, and the value is the maximum value sum. Okay, now let's start coding. So the first thing I want to have is a cache. So it's a cache, and then the key in the cache is the tuple, and it is the left boundary and the right boundary of the array. Okay, and then because I want to visit the tree, so I have a recursion function. I call it calculation cal, and so in the function, the parameters is the left boundary and the right boundary. Then for every node, it will return the maximum value of all the subtree. It should say, I should say the maximum left node of the subtree, and also the sum of the non-leaf node. So here I would like to have a maximum value and also the sum. Okay, so now let's start. So if I already have the result stored in cache, I don't have to calculate it again. So let's check if there is anything in the cache. Left boundary and right boundary. And then since it's a recursion function, so I also like to write the base case, which is when the left boundary is the right boundary. It means there is only one element remain in the array. So I can show that this is the leaf node. So first I put the results in the cache. So what is the result? So for the leaf node, the maximum value is the itself. So I could say it's the element itself, and the sum is 0 because when it requires to return the sum of the values, it just requires to return the values of each non-leaf node. So since this is a leaf node, I just return 0, so I won't include this value in the sum. Left and right. Okay, now let's go to our main function. So think about if now I have the elements like this one. If this is my array, then I could have multiple ways to split the array. So I can have the 1 as the left subtree and 2 to 7 as the right subtree, or I can have 1, 2 as the left subtree and 3 to 7 as the right subtree. So basically I have to have a iteration for the I. So for the I set it to the start index of the right subtree. So for this example, it means the index 2. Okay. And so it will start from L plus 1 because I have to add this one element in the left subtree, and also I have to also remain at least one element like this one as the right subtree. So here I need to put R plus 1 because in the Python range the end is not inclusively, so it's not inclusively. So here you actually just will just use the R. So for every I will call the so first I will call the left subtree. So I will return the left boundary of the left subtree is the L itself, and it may goes to the I minus 1 since I is the start index of the right subtree. So it will goes from L and goes to the I minus 1. For the right subtree, I will start from I and then goes into the R, into the last element in the array. So for every recursion call, I will return the maximum value and the sum. So let's say it's the left maximum value and the left sum. And I also have the right maximum value and right sum. Okay, so I also want to have a results total and initialize it at negative number. So this is the value I want to return as like this one. So maybe I should call the result sum, and also I have to return the maximum value, so I will also have a result maximum value. Okay, so this one for the sum, I should initialize it as a maximum number, and then for the maximum number, I should initialize it as a negative infinity number. Okay, so now I have the left maximum number from the left subtree and the maximum number from the right subtree. So I could have the node value. So it is the left maximum multiplied by the right maximum, and then I can have a total. It means the total sum until this node. So it is the sum from the left subtree and the sum from the right subtree, and also the node itself. So it is node value. After this iteration, I want to check if I should update my result sum, because I want to keep the sum as small as possible. So whenever the total is smaller than the result sum, then I want to update it. So, and I also want to update the maximum value. So it is the maximum value from the left max and the right max. Okay, and after I finish the 4 iteration, I can put the results in cache. Left boundary and right boundary. It is result sum and the result maximum number. And return okay, and now I call the calculate function, and the left boundary is the first element and the right boundary is the last element. And since it returned a tuple, but I just want to take the sum, so I have to use this to take just one element from the tuple. Now let's check. Okay, here I made an in. Here I have a bug. I should put the maximum number and then put the result sum. Okay. Yeah, it passed.